So likewise for max, if I sorry min. So if I want to define W, I don't think I've used W. If I want to do min, what do? I can do something very similar. Pw of m, since I don't like, let me use a different index. What is P? This is for the independent integer valued case, it is, I just write the result and we will explain it. Px equal to m, Py greater than equal to m plus Py equal to m. If I put y equal to m, what will I put here? Strictly greater than m, correct. So this is again for independent xy. Of course, if you want to remove the independence, you will have to club this as a joint event like we did here. Otherwise, it's right. As long as they are integer valued, you can write you can write the equivalent here, which I did not write, but integer valued and independent gives you something like this. And it turns out that for the geometric case, this simplifies it in a very interesting way. That is, when x and y are both geometric, independent geometric, let us say with both are IID. So we will just do that one calculation. I hope, let me before proceeding further, minimum is okay, right? So how do I define minimum? W equals x for x smaller than equal to y, and it's y otherwise. So once you know x and y, you know both the maximum of xy and the minimum of xy. Remember, one of the x and y have to be the maximum and the other one has to be the minimum. That is another thing always keep in mind, because when you look at joint x and distribution of max and min, one of them has to be x, the other has to be y. Unlike the case of x plus y and x minus y, when you generate new values, when you are taking maximum and minimum, you are not generating some new numbers, you are taking the existing numbers and relabeling them. So anyway, for W equal to min xy, let us say x and y are, let me say, tilde geometric half IID. In other words, they are independent and identically distributed with parameter geometric parameter half. Then you can show that what is P pi greater than equal to m will be half power m minus 1. What is P x greater than equal to m will be half power m. These things come from the geometric distribution. Remember we did this earlier? Did we or did we not? I am sure we did it. This is the probability that there is no success up to the trial m minus 1. This is the probability that there is no success up to the trial m, including m. So that is why you get m minus 1 here, you get m here. Now if you put it all together, maybe I should ask you to do it. Why don't you do it and tell me what is Pw of m? First of all, what is omega w? That we should do first. Omega w is what? X can go from 1 to infinity, not 0 to infinity, right. So in geometry case we are starting the trial counting from 1. So omega can be 1 itself, and there is no limit on how large omega can be potentially, right. So you have to allow all values, all integer values, non-negative integer values there, all positive integer values, right, 1, 2 up to 1. So what is this? If you plug it all in there, what is x equal to m? So the probability that x equals m is half power m minus 1. So if you do all this together, you will find that Pw of m, you get this interesting expression. This is half power, 1 by 4 to the power of m minus 1 into 3 by 4 for m greater than equal to 1. So P, remember P x equal to m is what? Is half power, for the geometry case the probability of with geometry half, right, geometric the success parameter half, right, well, what will be P x equal to m? It will be half power m minus 1 into half, right. So just half power m, no, sorry, let me, right. So this is, that's true. So this is equal to the probability that x equals m. Interestingly, for the half case you get this x equal to m and x greater than m have the same probability. There has been no success up to event m, up to m minus 1. That is when, so the x equal to m means what? There is no success in the first m minus 1 trials. So you get the probability of half power m for having the success at the end trial, or you get half power m for succeeding in the future. So the geometric PMF has some very interesting properties like this also, right, that these two have the same, but for that of course you need half. It does not work for any p, as you can check, right. So this is this, and similarly Py equal to m is also, because here IID, Py equal to m is also exactly half power m. So if you manipulate you get this. What is this PMF? Geometric with what success parameter? It's 3 by 4, right. What is the intuition behind this? The minimum of two independent geometrics, IID in this case half is, so when if you toss two coins separately and you count the number of trials till you get the first head, what is W going to be? W is going to be the minimum of the two counts. So it turns out that W equal to m will be getting x equal to m or y equal to m, I mean the first one. Anyway, so I can't think and talk at the same time, so let me, so you can go back and think about this. This makes perfect sense intuitively, right. Let me not try to find words to explain what I mean, but please go and think about it. Okay. So please, right, basically 3 by 4 is the probability, is what? Is what probability? The probability of getting ahead at the any toss, either x or y, is it not? Supposing you look at the probability, now I can say it correctly, right. If you toss two independent coins, fair coins, right, what is the probability of getting ahead here or here? It is 3 by 4. Is it not? That is the intuition I am asking you to get. So the minimum is, so when do you say that W takes a value 3? You get a head here or a head here, the first one. So that experiment will succeed with probability 3 by 4 now. It is not going to, right, when you are tossing two coins and you are looking a head here or a head here, then if it, okay, you get neither, then you toss one more time. So obviously that is geometric. The composite right, experiment is geometric with probability 3 by 4, where you are only looking at head here or head here. So that is what is reflected in this. So again and again let me emphasize, right, you all these probability calculations wherever possible they must be capable of being explained intuitively. Of course not everything is intuitively explainable, but certainly this is. This is okay. Any questions on this? Okay, so we have successfully manipulated a few things so far. Let me, with this I am pretty much done with whatever I wanted to say in for discrete random variables. So but we do have a few minutes in today's class. So what I am going to wind up with is a bit more of one more manipulation regarding, no, okay, let me also maybe this there is a manipulation here. This the same case of x and y being independent geometric IID half, right. I wish I hadn't erased all this, but anyway. This geometric half IID, right, has some very interesting probabilities. So what is the probability that x equal to y? If somebody asks you this question, what would you say? How do you write this out?
Geometric of half again.
This is x equals y. This is not a we are only looking at an event here. We are not looking at a random variable in the sense you can write an indicator random variable for this, but that does not help you find the probability. So you have to actually find it. So this will be, I have to take this pxy of kk and sum over, right, x equal to k, y equal to k. So what values of k can x and y, what values of k do I need? I have to go from 1 to infinity. So this is physically, right, you are tossing these fair coins, 2 of them, and you are looking at having the same number of trials in both camps. One person tossing in this corner of the room, the other person tossing in that corner of the room, and you are looking at the event that the same number of trials is required to get ahead. What is this? This is the probability x equal to k, y equal to k, because they are independent, they will factor, and somebody actually said the right answer, it is 1 by 3. Okay, fine. What is the probability from this? Can you infer that x is going to be greater than y and less than y? 1 by 3, 1 by 3. Remember I said symmetry can always be used to, right, to tell you what is, so when you have IID random variables, probability x greater than y will be equal to the probability x less than y, right. So here remember I am not using equals anywhere, x great is strictly greater than y and x strictly less than y, right. I am deliberately leaving out the equality, because the equality is, as we said earlier, it is not, you cannot add it to either side, then you destroy the symmetry. So here so all 3 events now have the same probability in this case, which is very specific to geometric half. But in general, if somebody asks you to find this x probability of x greater than y, you should be able to set it up from first principles, right. You add over the triangle, the open-ended triangle where x is greater than y, right. Assuming x and y are both integer, right, positive integer value, whatever, there will be a portion of the xy plane that will correspond to the event x strictly greater than y. You have to add up the probabilities of all those points in that portion. I am now going